Students, in this video we will discuss the structure of alkynes, right? So to understand the structure of alkynes, we will write the electronic configuration of carbon in the ground state. We know atomic number of carbon is 6, right? So electronic configuration of carbon in ground state configuration of carbon it is 1s 2 2s 2 2px 2py 2pz 1 2 3 4 5 6. This is the ground state configuration of carbon. 2pz is empty, no electron is present in 2pz, right? Now after that we will write the excited state configuration of carbon atomic number 6. Now it's excited state configuration. Excited state configuration. Excited state electronic configuration of carbon. When this is the valence shell of carbon, right? Second shell is the valence shell. Now when electron absorbed energy, then it start jumping from 2s orbital to empty 2pz orbital, right students? So electron start jumping from 2s to empty 2pz orbital after excitation. So the configuration will remain. There are 2 electrons in the core, that is 1s2, while in 2s there is just 1 electron, 2px 1, 2py 1, and in 2pz we have 1 electron. This is the excited state configuration of carbon, right? Now carbon in hybridized state. Hybrid state configuration of carbon. Hybrid state configuration. Since we know in alkynes the mode of hybridization is sp, right? In alkynes the mode of hybridization is sp hybridization. It means 1s and 1p, they will intermix. So what is a hybridized state configuration of carbon? In 1s2 2 electrons are there, right? While 2s and 2px, they will intermix. 2s and 2px, they will intermix, right? 1s and 1p. So the mode of hybridization is sp. 1 electron in one sp orbital and 1 electron in another sp orbital. 2py and 2pz do not participate in hybridization, right? Like this. Now students, we draw their orbital structures. We know the shape of s orbital. S orbital is spherical in shape, right? Like this. This is 2s orbital of carbon. 2s. Now 2s orbital of carbon will intermix with 2px orbital. This is 2px orbital of carbon. This is 2px. 2px orbital of carbon, right? Now here, after the intermixing of s orbital with 2px orbital, we get a hybrid orbital which consists of one larger lobe and one smaller lobe. Actually, when here we have 2px orbital and here s orbital is fused here in 2px orbital. The lobe of 2px orbital where the s orbital is fused, this lobe becomes larger, right? This lobe becomes larger like this. one lobe becomes larger while another lobe becomes smaller. Students, how many orbitals are mixed to each other? आपस में कितने ऑर्बिटल इंटरमिक्स हुए? दो ऑर्बिटल इंटरमिक्स हुए. ठीक है, तो दो ऑर्बिटल के इंटरमिक्स होने के बाद हमारे पास कितने हाइब्रिड ऑर्बिटल बनेंगे? यस, वी गेट टू हाइब्रिड ऑर्बिटल्स, राइट? एंड द शेप ऑफ ईच हाइब्रिड ऑर्बिटल इज कंसिस्ट ऑफ वन लार्जर एंड वन स्मॉलर लोब. सो वी गेट टू ऑर्बिटल्स, right? Two hybrid orbitals, and here they are consist of one larger lobe and one smaller lobe, like this. sp hybridized orbital of carbon arrange themselves in such a way that the bond angle in between them is 180 degree, right? So sp hybridized orbital of carbon, one sp hybridized orbital, and here we have the second orbital. Here you can notice the bond angle in between them is 180 degree. Sigma bond is always formed by the head-to-head or end-to-end or linear overlap of half-filled atomic orbitals in such a way that the sigma electron density lies at the internuclear region, while pi bond is formed by the sidewise or lateral overlap of half-filled atomic orbitals in such a way that the pi electron density lies below and above the nuclear axis, right students? So here we see in ethyne, first of all, between carbon and carbon, sigma bond is formed between carbon and carbon, and sigma bond is formed between each carbon and hydrogen, right? And pi bond is formed like we have by the sidewise overlap of one carbon, half filled p orbitals, right? Like this, overlapping of p orbital, like this way. So sidewise overlapping of orbitals will form pi bond. Let's see how sigma bond is formed between carbon atoms. This is the carbon, and here sp hybridized orbital of carbon atoms, two sp hybridized orbitals, while this is 2py orbital of one carbon and 2pz orbital of this carbon atom. Similarly, here another carbon, sp orbital of carbon, this carbon, two py and 2pz orbital. This is sp orbital. This is 2py and 2pz. sp, 2py and 2pz. Now see how first bond is formed between carbon and carbon. A sigma bond is formed by sp overlap of sp orbital of one carbon with sp orbital of another carbon. So here we make again we make pi orbitals, 2pz, 2py and 2pz. Here we have second carbon, sp orbital of this carbon overlap with sp orbital of this carbon. Right. Again we make the 2py and 2pz orbitals. This is 2py, right students, and this is 2pz orbital. Now here the overlap of sp orbital of one carbon with sp orbital of another carbon. So this overlap is sp overlap. As a result of sp overlap, we get the first sigma bond between carbon and carbon. So here sigma bond is formed. sigma bond is formed between carbon and carbon. Similarly, we have sigma bond between carbon and hydrogen. So how sigma bond is formed between carbon and hydrogen? By the overlap of sp orbital of carbon with s orbital of hydrogen, since the valence electron of hydrogen is present in s orbital. So here we have sp s overlap, sp s overlap here. This is, again we have here sigma bond by sp s overlap. This is hydrogen. Likewise here we have sp s overlap. We have sp s overlap. Here we have sigma bond, which is formed by sp orbital of carbon, overlap of sp orbital of carbon with s orbital of hydrogen. So sigma bonds are formed. Then pi bond is formed by the sidewise or lateral overlap of p orbitals, that is 2py. This is 2py, right, and this is 2pz, 2py and 2pz. So first pi bond is formed by the sidewise overlap of 2py orbital of one carbon with 2py orbital of another carbon. We get here the first pi bond, right, and the second pi bond is formed by the sidewise overlap of 2pz orbital of one carbon with 2pz orbital of another carbon. So in this way, here we get pi bond, first pi bond, and here we get second pi bond. So the mode of hybridization of carbon atom in ethyne is sp. The cloud of pi electron is present cylindrically symmetrically about the carbon-carbon sigma bond. I hope this is clear to you, students.